Behind me is one of the University of Tennessee's experimental greenhouses. It's a glass structure. Glass has a transmissibility of about 90%, meaning 90% of the energy from the sun goes into the greenhouse enclosure. In this area, the sunlight's fairly strong, and what you have on the inside of this greenhouse is a series of shade cloth blankets on the inside that reflect some of that energy out. This is a sawtooth profile structure, meaning you have a lot of roofing vents, and the overall height, it's probably on the order of 18 feet tall, the finished floor to the peak of the apex, and that provides a large vertical column for that buoyancy effect to stratify the hot air, and that keeps the lower areas cool. And what I've noticed is a significant number of swamp coolers on this system, so that it doesn't cost any more energy than just the fan power to be able to push that air, the forced ventilation. So it's a nice, very expensive facility, and that's the problem. Even though systems like this, the temperature controlled environment, they're nice, they work effectively, the glass is going to last for decades, it's a matter of cost. And the average American just cannot afford that. So using a system like this is not a viable solution for local food protection. But it's interesting to take some of the lessons learned from this system and incorporate those in less expensive models. So just showing you some of the greenhouses on the interior, what they're doing here. So your water supply here is fed from the central corridor, which I think is kind of an interesting design. So in this case, the recommendation was to have the shade cloth on different circuits, so you can control one independent of the others. And the other recommendation for this was to have independence on the lights. Instead of having them all on the same circuit where you have to turn them all on at the same time, have them separately controlled with different switches. And that helps you better optimize your greenhouse space in this particular glass facility. So this is exclusively a polycarbonate structure. It's about 6,000 square feet thereabouts. The nursery manager wasn't sure, but she felt it was around 20 years, if not more, on this. And there is definitely some yellowing you can see. What's interesting too is the lower elevation here in Tennessee compared to the Intermountain West. It really, I think, enables a slower yellowing process. So if this is 20 or 30 years old, not as much yellowing as you'd expect. That's why I don't think that this is 30 years old. So probably 20. You can also tell from the amount of dirt in the channels. The ends probably were not adequately sealed, or there's just a lot of algae growth in the middle due to condensation buildup. So this is kind of an interesting greenhouse because what they have is a series of bays. Each bay with runs into a gutter, and the gutters, there's a total of 3 gutters on one side, 2 gutters on the other side, and basically it ties the whole thing together into a single unit. So it's perfectly modular for experiments in various sections of it. Nice greenhouse, really nothing more to say about it. One thing that's worth pointing out is just the few number of screws that are used to fasten the polycarbonate. As you count this, if you look at the bottom, there's a J channel on the bottom, that J channel trim on the bottom. So you're going to have screws going through that. They didn't use an oversized washer on the bottom, which I think is interesting. They did here, but it's a very small washer, probably on the order of maybe 7/8 of an inch. We use 1.2 inch or 1.5 inch. We wouldn't go that small with our wind load. Similarly, you have the trim up on top, but overall there's just a handful of screws. I think if you counted it up, you'd be on the order of about 15 screws for an entire panel. So it seems a little light, but that's how they're doing it here. I wanted to show you their polyethylene high tunnels. What they have here is 2 layers of polyethylene. The greenhouse manager confirmed they actually change those out, the polyethylene, about every 5 years on this system. This fiberglass system is very old. This was one of the more original ones, but clearly on the order of 30 years. So this is an older high tunnel. Here you can see the fans blowing through. Same setup. They have 2-layer polycarbonate. I didn't feel it, but I'm gauging. It's on the order of 6 millimeter. Yellowed, once again, about 30 years old. 2-layer polyethylene to shake cloth. Similar structure here. Once again, a very yellowed polycarbonate, about 30 years old. So this is their high tunnel installation. It's not a very large installation. Certainly isn't as large as other universities I've toured, but it does give you a feel for some different ideas in terms of greenhouses.